All right, so we're going to be learning about the observable design pattern in this video. Um, First of all, this is a very useful design pattern for making sure that the changing state of one object is dependent and constantly updating as another object is updated. And this relationship is defined with both an observer typed object and an observable typed object. So for the example today here, I'm going to be using this class, person.java, as the observer, and this class, mail.java, as the observable. So it's a very basic example, but I guess what I'm trying to point out with this relationship is as mail comes in to a post office, basically as you create a new mail object, you want the corresponding person to be automatically updated of that change. So the mail is going to have an ID number, as seen here, and so is the person. And obviously the person here is the observer, and it's observing the observable mail objects. So some of what I've defined here so far is the ID number, a status of whether the person is waiting or not, and when you define a person, you say this.id equals ID, and you instantiate all of its values. Also have a getter so that you can reasonably access its ID number. Now, what makes this class special is it implements the observer interface. This was a library used and created in standard JDK, and it basically just helps set up a framework so that you can reliably create this relationship without having to make your own observable functions or observer functions. It's kind of just built in for you to use for whatever kinds of objects you need it to be used for. So an observer must implement the function update. Update basically will be called within the observable class, and so that's within the mail class. And basically, when observers are notified, this triggers any observer, which we can assume that a person will be observing a mail object. It'll trigger the update function to be called. So let's go and check out this class now. In mail.java, we have the two methods that are required to be called. One of them is setChanged, and the other is notify observers. So whenever a new mail object is instantiated, so as you can see here, this is the constructor for the mail class. The first thing you do is you take in the ID, and then you flip through a list of people, and if the IDs match, you add the person as an observer for that mail object. So once the connections are made between the person and the mail, we call this function has arrived, and that'll trigger the updates to be called in person. So basically, anytime a new mail object is created, the corresponding person will have their own information or data updated to match incoming mail. So this is very powerful because rather than needing to define these interactions within a script or a main method from which you're making changes in, you have one change automatically occur when another change occurs. So let me show you how this works in the main method. So the first thing we want to do is define some people. And I think the way I set mine up is you're going to need to define them within an array list. So we'll have an array list of people. And these will hold any person which is waiting for mail. So we'll say people.add, and we'll say new person, and we'll give them the ID 1. And we'll do that again, except this person can have ID 2 or something. And, for this example, it's fine just to have 2. And let's say a new piece of mail comes in. So with a new mail object, we want to show them all of the people that are available so we can figure out which person needs to be updated. And we'll give it an ID so we know which person is going to be connected to this mail object. Now, when we call that and we run this main method, we can see that person one's status is updated as mail with the same ID comes in. And we can even use this get status method and prove that person two is still going to have the data state defined as waiting for mail. So we can say for person P in people, let's say P dot, what's that method called? Get status. And we'll print so we can see those results in runtime. What's wrong here? Let's see, I must have defined something weird. Oh, we're already printing here, so we actually don't need the print statement twice. So this should be enough, and let's see what happens. So as we can see, one has received their mail, and two is still waiting. So pretty basic example, but it should give you an idea of how you can define changes with this design pattern rather than having to define them explicitly in a separate class. And this will really help organize your code and make sure that every object is always in the correct state that it needs to be in.